This is assignment 2.2 part 2, blood flow. Vascular shunt is during exercise your body will need the blood at the working muscles to deliver the oxygen where it needs to be delivered so it can get rid of the CO2 and so your muscles can work for longer. This can help with long distance runners such as Mo Farah, so he can continue doing the 10,000 meters without really slowing down at all because his muscles will always be getting replenished by the oxygen. Vascular shunt is where blood vessels contract at places where the blood is not needed, so it will wait there ready to force the blood to places it is needed, such as the legs and the muscles that are actually connected to the leg bones. Vasodilation is the dilation of blood vessels which decreases the blood pressure. This is found in the diastolic blood pressure when you're exercising. It will decrease due to vasodilation. Vasoconstriction, on the other hand, is when blood vessels contract, which then increases the blood pressure, which will be found with the systolic blood pressure. When you are exercising, you can find that will go up because of this. Here is a graph that you will find shows breathing rate during steady state exercise. After a certain amount of exercise, you can see that it does start to plateau on the graph. This is due to the oxygen consumption being the same as the demand, so the CO2 is getting removed at the same pace that it's being produced. Because you've been working really hard, your body will build up this oxygen debt that it needs to repay, which is why the graph shows that it doesn't go straight down. It goes down then starts to steady out. So if you didn't need to repay this oxygen debt, then it will just plummet straight down to the normal level and then just go steadily from there. What is tidal volume? Tidal volume is the amount of air someone will inhale in one breath. During steady state exercise, your tidal volume will most likely increase. This is because you need more oxygen in your body so it can be supplied to the working muscles, get into the muscle fibers, diffuse into the muscle fibers, get rid of the CO2, which is poison to your body. It's toxic. You just don't want it in your system because it is really bad for you. Hence why we breathe out the CO2 but breathe in the oxygen, because the oxygen replaces it. It gets rid of it. So that's why you start breathing really heavily and really fast. It's to get more oxygen into your body so you can match that production rate of the CO2. Here we have two graphs showing oxygen dissociation curve, or the oxygen dissociation curve. The aerobic system. So after the lactic acid system, if there is a presence of oxygen, then instead of lactic acid being produced and forming, then there'll be an enzyme called coenzyme A, which causes pyruvic acid to turn into acetyl or acetyl coenzyme A. This takes place in the mitochondria. The next step is called Krebs cycle. This is where the acetyl coenzyme A turns into oxaloacetic acid, which then turns into citric acid, and this will then go into one of many things. Either more oxaloacetic acid, CO2, hydrogen, or into two phosphate molecules, which will then be resynthesized to create more energy for the body so you can exercise for longer. The final step of this, the aerobic system that is the electron transport chain. The transport ions NAD and FAD will bind with hydrogen, and they will either form hydrogen ions or hydrogen electrons. The ions will form H2O, and this will keep the body from overheating. This is also known as sweat. The electrons will turn into 34 phosphates ready to be used as energy. This is a very slow procedure and is used in long distance events, which is why when you look at this system, Mo Farah might be mentioned because he takes part in 10,000 meter, 5,000 meter events, which are really long distance if you think about it. And this is the system that his body will be using to resynthesize that energy so he can keep going for longer without tiring, so his muscles can just keep working. What is a muscle spindle? Muscle spindles are receptors or proprioceptors that detect if a muscle is stretching. This is what they look like. As you can see on the right hand side, there is an image of one. They send a message of what they detect to the central nervous system via nerve fibers. This is then processed by the brain to determine where each body part is. If the muscle is stretched too quickly, then the muscle spindle will detect this and prevent it from stretching too far as to help prevent injury. So we've looked at muscle spindles, but what are Golgi tendon organs? These are similar to the muscle spindles as they detect movement in the muscle, but these detect the tension, not the stretch of the muscles. This will also send a message to the CNS or central nervous system to help detect the muscle movement and where it is. The picture on the right shows how it is connected with a sensory fiber, which helps detect it all and then send it back to the CNS. When the GTO is active, it inhibits muscle spindle activity in that muscle. And the reason that it does this is so a deeper or further stretch can be achieved without the muscle spindle making sure that you don't cause harm to yourself, because if you stretch too far, then the muscle spindle will come into play and try and stop it from stop you from overstretching to prevent injury, so you don't pull a muscle or do anything worse. Thank you very much. This has been assignment 2.2.